earlier we talked about the Chinese remainder theorem as a way of solving these multiple mod remainder constraints. But we're going to take the original one where we had a number divided by 3. X divided by 3 had a remainder of 1. X divided by 5 had a remainder of 2. And X divided by 7 had a remainder of 3. And we're going to solve this using mod without the Chinese remainder theorem. So the remainder theorem is awesome, but it's not the only way to solve it using mods. And what we're going to do is we're going to take each of these, X congruent to 1 mod 3, and X is congruent to 2 mod 5, and X is congruent to 3 mod 7. And we're going to solve this using our modular arithmetic and some algebra powers. So we're going to start with this one, and we're going to write this as an equation. By the way, before we get started, I would suggest that you use, for your variables, use Q, R, S, T, and if you have to, U and V. We're going to do these 3, so we're just going to use Q, R, and S for variables. So for this first one, the linear equation of it is going to be X is equal to 1 plus 3Q. Because remainder is 1 and we're dividing by 3. Right? So then this is where Q is an element of Z. And then when we do the next one, X is congruent to 2 mod S, we can say that 1 plus 3Q is congruent to 2 mod 5. See how I did that? So I just took this and turned it into a linear equation, and then I moved it to the X position to the second one. And then, of course, you're going to get 3Q is congruent to, if we subtract 1 from both sides, 1 mod 5, right? And then if you think about it, what the solution is going to be, by inspection, Q is going to be 2. Q is going to be equal to 2 mod 5, because if you have a 2, 3 times 2 is 6, minus 1 is a multiple of 5. So now Q is equal to 2 plus 5R we're going to use, where R is an element of the integers. So we've got that going for us. Now I'm going to take this one here, and I'm going to write it down here. X is congruent to 3 mod 7. So then what we can do with that is you can say, all right, go back to what X was, 1 plus 3Q mod 7, and you probably can see what's going to happen here, is that now we're going to put in for Q, we're going to put in 2 plus 5R. So this is going to be 1 plus 6 is 7 plus 15R, congruent to 3 mod 7. And if you subtract 7 to both sides, you get 15r is congruent to negative 4 mod 7. This is what's so interesting about this kind of math. 15r is congruent, well, 15r is congruent to 3 mod 7. So now you're going to do your inspection piece again. By inspection, then you're going to get, I think it's going to be 3, because if r is equal to 3, what you'll get is 45 minus 3 is 42, and 42 is divisible by 7. 15 times 3 is, or 2 is 30, minus 3 is 27, not divisible by 7. 15 times 1 minus 3 is 12, not divisible by 7. 3 is the first one that you end up with, and so we get the final grand finale formula for r, which is 3 plus 7, and now we're going to go with, I'm going to use s this time. So then once you have that, then you're ready to go back and pull all of these together, q and x. So let's repeat those. We have x equal to 1 plus 3q. We have q is equal to 2 plus 5r, and r is equal to 3 plus 7s. Then you just take out the original x equal to 1 plus 3q. Remember, this is q. And then for q, you put in 2 plus 5r. So now we're going to put an r in here. And r is 3 plus 7s. So when we put this together, you're going to get x is equal to 1 plus 3 times 2 is 6. 3 times 5 times 3 is 45. 3 times 5 times 7, or 35 times 3, is 105s. And when I put these together, you're going to get 5152 plus 105 times the letter s. And there's the answer we got without using the Chinese remainder theorem. So let's try it one more time. Take another example. This time we're going to be using Q, R, S, and T. So we're going to have all of these. And the key step is definitely going to be using the mods to reduce these. So let's do it. X is equal to 0 plus 2q. All right? And then the next thing that you're going to do is you're going to go 2q is congruent to 0 mod, I think that's 3. Because this is the second one. We're taking this one here. X is equal to 2q because it's 0 plus 2q. Then the next one is 2q, which is your x, is congruent to 0 mod 3. Okay, now by inspection, you're going to get q is going to be equal to 3. Or q will be 0. That's the easy one. It could go 3, but minus 3 is 0. And so now we can say that q is equal to 0 plus 3. Next one is r. All right, now we do the next guy, this one. We're going to go for this one, x is congruent to 1 mod 5, and x, of course, was 2q, and q is equal to 3r. That's 1 mod 5. 6r is congruent to 1 mod 5. Now, you might be wondering, when do I do that inspection thing? You do the inspection thing when you have to solve a mod that has a variable on the left side. So we have that there and we have that here. We're going to do another by inspection. And I think in order to get this, I think r is going to be equal to 1, because 6 minus 1 is 5. So then we'll get r is congruent to 1 mod 5. And so therefore you're going to get r equal to 1 plus 5. The next letter is s, of course. And then I'm going to go back up here and take this one. And this is going to be x is congruent to 6 mod 7. Got a little bit of work here, but we can do it. X was 2q. Q was 3r. And r is 1 plus 5s. So we're going to nest all of that together. X is going to be 2 times q, and q is 3 times r, and r is 1 plus 5s. Congruent to 6 mod 7. Okay, so this is going to be 2 times 3 is 6, plus 2 times 3 times 5 is 30. S is congruent to 6 mod 7. And you guessed it, if you subtract the 6, you get 30s is congruent to 0 mod 7. So they made it easy for us. S is congruent to 0 mod 7, just again by inspection. You look, whenever you see something times a variable in a mod, then you're going to do the by inspection thing to figure that out. So then that final equation is going to be s is equal to 0 plus 7t. So now we put them all together. We have q is equal to 3r. We have r is equal to 1 plus 5s. S is equal to 7t. And then at the beginning here, x was equal to 2q. So there's a lot of nesting that we're going to do for that. So here goes. Final stroke here. X is equal to 2 times q, which is 3 times r, which is 1 plus 5s, which is 7t. So x is going to be equal to 6 times, well, I think it's just going to be 6 plus 35 times 6, 210 t. So without doing the Chinese remainder theorem, which, by the way, if we multiplied 2 times 3 times 5 times 7, what's that m going to be? 6 times 35 is 210. That's my big M, and that's the big M down here, and my answer is going to be x equal to 6. No way does that work. 6? 6 is congruent to 0 mod 2, yes. 6 is congruent to 3, 6 is congruent to 0 mod 3, absolutely. 6 minus 1 is 5, mod 5, sounds good. 6 minus 6 is 0, mod 7, that works as well. It is 6. So that's how you find the solution without the Chinese remainder theorem. The theorem is quicker, but this is kind of good too.